Hi, my name is Tom Klepper, and we're going to kick off this basic electrical circuits series of classes. It'll be 3 to 4 to 5 classes taken over several weeks, and we're going to learn about electricity, circuit sensors, and Arduino microcontroller boards. So the purpose really is to give you an introduction to what electricity is, including voltage, current, and resistance, basic circuits, very simple circuits, and sensors, and how you can interface them to Arduino microcontroller boards. So what are some examples of sensors and devices? Well, certainly you might want to measure temperature, humidity, light. You're going to want to output like LEDs, run servo motors, have input switches. These give you some ideas of things that you're going to want to use as sensors into your projects. Then we're going to learn how to interface them to these little Arduino boards, and we'll talk a little bit about what the Arduino board is, which is programmed in C. And then finally, you may want to interface those boards to a computer, and we're going to possibly use VB.NET in order to do that. So Jesse had mentioned, hey, we should make up a little example project to see what people can do in the lab. So I made up this, I call it the Trace the Wire game. So it has some LED outputs, and it has lights, so it has also some sound. And essentially what you do is you take this loop of wire and you trace it along this Route 9 and try not to touch it, kind of like the old operations game. So you bring the loop here and you touch it to that to start it, and you trace it along the R, along the T, and then the 9, and you end up touching the loop to here to finish it, all without touching the loop to the wire. And if you do, it makes a sound. And this whole project includes things like 3D printed, so the edges are 3D printed, and this base was a laser cut out of acrylic. So it kind of gives you an idea of a project that you could do, and honestly, if you go through this series, you would be able to make a game just like this, as an example. So what is an Arduino board? Well, essentially it's a computer on a chip. And what can you do with that? Well, it has some digital inputs and outputs. So inputs might be from a push button or a switch, something like that. Outputs might drive an LED light or the servo motor. It takes analog inputs for different sensors. It has some timers in it so you can time things. You can interface it to a computer via the USB port shown right here. You program this in what's called the C language, which we will talk about at a later time. And there's so many example codes and projects on the internet, it's not even funny. That's what actually got me into the Arduino in the first place, because it's just ubiquitous. It's everywhere. You can go on to adafruit.com, pick some sensors, and they have the example code right on her webpage. It's open source, which means that you can get to the schematics and all the code, and everything is just freely available on the internet, which is nice. And they're low cost, so you can get a knockoff of this for about 10 bucks. And if you wanted to learn more about the Arduino particularly, go to this website, and everything you needed to know about it is right there with how to program it, example code, and everything you'd want to know. So where are microcontrollers used? So this gives you some ideas that garage door remotes would have them. Here's one right here. A simple computer mouse will have a microcontroller. Here's a carbon monoxide detector that has one, and even the Rambo control board for a 3D printer has a microcontroller in it. So like the Lulzbots that we have in the lab, runs off of a microcontroller. So something as simple as a mouse to as complicated as a 3D printer all run off of microcontrollers. So here is the outline for this course. So part one, we're going to go into current, voltage, and resistance. These are the basic parameters and concepts of electricity. And we're going to go into them a little bit deeper than you might get in other courses, because I think it's important to get a really good feel for what they are, to really understand them. And if you come out of this course and somebody asks you what electricity is, I want you to be able to explain it to them. The next part is how you put all these parameters together in what's called Ohm's law, and how you relate them to power, either power dissipated or power generated, or driving something that requires power. So that all kind of ties this electricity kind of story together. Then we move on to very simple circuits, schematics, etc., and sensors, which is the point. We want to interface these unique sensors in our projects to a microcontroller, and then of course we're going to learn how to program the Arduino using the C programming language. And then ultimately, if we have time, we'll figure out how to interface these Arduinos to a computer, either using Visual Basic.net or Python. Haven't really decided yet, but we'll see how it goes. So this course has some math in it, not too much. Here are the prerequisites, and just kind of go over them quickly. Some basic algebra, so variables, when we talk about some simple formulas and maybe some symbols, ratios, fractions, and percentages, and I'll talk about them next, but just simple formulas is what this is going to fall out. Basic geometry, area of simple shapes, and then finally talk about units and these SI prefixes, which are really important when describing very big and very small numbers, which we do in electrical engineering a lot. So when we talk about basic geometry, I'm just referring to different geometries and can you calculate the area of them. So as an example, we're going to talk about wires, and when I refer to what's the cross section of the wire, I'm talking about the area of this wire. We would need to be able to calculate that with these formulas. So nothing really more complicated than that. And we talk about units. It's really important. As a kind of silly example, I was at Asia Pacific recently for business. We went to South Korea, and the Korean won is the currency of South Korea. And so I brought back 1,000 won to give to my wife, which sounds really impressive until you calculate what it is in US dollars using this kind of ratio formula. You can convert the 1,000 Korean won to dollars, and it's only 84 cents, so maybe not as impressive. But here's a more practical example. So you're calculating your gas mileage. So first you fill up your tank of your car. You drive, let's say 300 miles, and then you fill up the tank again, and notice it takes 12 gallons of gas. So the way you calculate your gas mileage is you take the number of miles divided by the number of gallons, so 300 miles divided by the 12 gallons it took to fill up, and you get 25 miles per gallon. And so this is how you would write that and how you say it, 25 miles per gallon, or miles divided by gallon. So this is the kind of thing we're going to get involved with in terms of units and conversions and calculations. Nothing more really fancy than that. Here's another example. We're going to do unit conversion. So let's say you need to convert that gas mileage to kilometers per liter. So maybe you're going to the UK and you want to know what that gas mileage is. So we take our 25 miles per gallon, and then you write it like this. So it's 25 miles per 1 gallon. You multiply that times the conversion factor of 1 gallon per 3.78 liters. Multiply that times 1.60934 kilometers per mile. And when you write it like this, you can cancel the miles in the numerator and denominator, cancel the gallons in the numerator and denominator, and you're left with just kilometers per liter. So when you come over here, you just need to multiply the numbers together. 25 times 1.6 divided by 3.78 kilometers per liter, and you get 10.63 kilometers per liter. So this gives you an example of how you would do unit conversion if you would need to convert something. We're not going to do a lot of that, but it is important to know how to do it, let's say. Maybe another example is area unit conversion. So you want to convert the area in square feet and need it in square meters. So maybe the example is you have a closet that's 10 feet by 5 feet, and you want to put carpet in it. So, but they need it in terms of square meters. So you take the 50 square feet, which is 10 times 5 feet squared, and you would write it like 50 feet squared over 1 times the conversion. Now this way you would do 1 meter over 3.28 feet, but then you would square that quantity, and that becomes 50 square feet times 1 meter squared, because you square the meter, and the 3.28 squared is 10.76 feet squared. You can't see it under the little red there, but there's a 2 there. So now your feet squared cancel, and I'm left with just meters squared, which is 4.65 meters squared. So that's how you do a unit conversion when you're talking about area. Again, we're not going to do a lot of this, but it's important to know how to do this stuff if we need to. And the next thing we talk about units, I mentioned meters, kilometers, liters. These are all things that we're familiar with, but we are going to introduce a few units that we're not familiar with. So one of them, when we talk about voltage, will be volts, or we use the unit of V. Current is measured in amperes or amps, so we'll use the unit A. Resistance is measured in ohms, or uses this omega symbol. So when we see this, we say it's ohms. And then finally, power is measured in watts, or just W. So we're gonna talk in depth about what these are, but I just wanted to throw out initially that the fact that we're going to be introducing some new units. So V for voltage, A for amps, the omega for ohms, and W for watts. So the SI prefixes. So this is how we're going to deal with really large and really small numbers. There's just too many zeros to write. Maybe we're lazy, but it just makes it easy to read and to deal with. So here is the SI list of all the prefixes. So these prefixes up here are used for really big numbers, and these prefixes down here are used for really small numbers. So in this course, we're only going to use 4 of them. We're going to use mega, kilo for the big numbers, and milli and micro for the small numbers. So as an example, if I say milliamps, or milli times amps, you write it as little ma. So it's ma, milliamps, is the same thing as taking the scale factor, 0.001 amps. So this is basically saying milliamps is equal to 0.001 amps. So it's just replacing the m with the 0.001 scale factor. Or if I write kilo ohms, you would just say k ohms, and that's equal to 1,000 ohms. So a kilo ohm, k, you just replace with the 1,000 scale factor. A kilo ohm is just 1,000 ohms. So this comes in really handy when dealing with really big and small numbers. So let's go through a few examples. If you want to learn more about this, here's the Wikipedia link. There's so much on the internet about all this stuff. If you ever have any questions about any concepts I'm going to go over, man, just put it in your search bar, and you'll find all kinds of stuff on the internet that refers to any of this stuff, really. So here's an example. We're going to talk about very small numbers. So 0.0021 volts. Again, too many zeros to write, so let's make it simple. We're going to want to reference that. Let's say put that into millivolts. So what we're going to do is we're going to multiply that by 1,000, which is simply just moving the decimal place over by 3. So you go 1, 2, 3. 1, 2, 3. My mouse is out. And that converts that to 2.1 millivolts. So the milli. So just easier to write. 2.1 millivolts is easier than putting all those zeros together. If you wanted to see how you go back, well, 2.1 millivolts, you can put zeros in front of the 2. It's the same number. But now you would just divide by 1,000, which is moving the decimal point to the left 3. 1, 2, 3. And then you get back your original 0.0021 volts that we had. So again, 2.1 millivolts is easier to write than 0.0021. And again, the milli just represents, if you just swap the m out and 0.001, 0.001 times 2.1 gives you 0.0021. It's the same thing as dividing by 1,000. We're just moving the decimal place over by three spots. So that's milli. Let's say you had even a smaller number, 0.000825 amps. Again, way too many zeros to write down. So here we're going to multiply by 1,000,000. We're going to move the decimal place over 6 spots. So you go 1, 2, 3, 4, 5, 6. And that turns out to be 825 microamps. So here we're going to use the micro prefix, which is, again, the micro is 0.000001. And you can prove that if you go backwards. You can say 825 microamps, replace the micro with that, is the same thing as dividing by 1,000,000. So you take the decimal place and you move it over, from here you go 1, 2, 3, 4, 5, 6. is the decimal place, and that brings you back to the original 0.000825 amps. So this kind of shows you how you would deal with the small numbers. Again, you can see representing this as a microamp is a lot easier. So let's take a look at the big numbers, so the really large numbers. Now, in what we're doing, we're mostly going to use large number prefixes for describing resistances. So let's say you have 4,700 ohms. We're going to divide that by 1,000, so you go 1, 2, 3, and that brings you to 4.7 kilo ohms. Again, a kilo is just 1,000 ohms, so this is basically saying it's 4.7 thousand ohms. You can go backwards. You can say 4.7 kilo ohms equals 4.7. You can add some zeros there. Now you can multiply times 1,000, so just moving the decimal place over by 3, and you're back to your 4,700 ohms. So that's how you could go from here to 4.7 kilo ohms and back. Again, the K is just 1,000. So when you see a kilo ohm, that's just 1,000 ohms, 4.7 thousand ohms. Let's take a bigger number. So here's 1,200,000 ohms. Way too much. So we're going to move the decimal place over to the left 6 times. Where's my cursor? So we're going to go 1, 2, 3, 4, 5, 6. Divided by 1,000,000, that gives you 1.2 mega ohms. And again, a mega is just a million. So you can go backwards by the 1.2 mega ohms. You just replace the M by 1,000,000, which is the same thing as multiplying times 1,000,000. So you can move it over to the right this time 6 spots, puts a decimal point there, and that brings you back to your 1,200,000 ohms that we had originally. And hopefully you can see that instead of writing this every time, it's easier just to write 1.2 mega ohms, where you understand that mega is 1,000,000. So, and again, we're only going to use the mega, kilo, and the million, the micro, for the most part. So here's the course series outline again. The first parts are going to be current, voltage, and resistance, and I'll probably record them each separately just because it gets too long. I'm going to try to keep each recorded segment to about 15 or so slides or less, and we'll see how it goes. So hopefully you've held on till now, and we can move forward with the rest of the series. Thanks for listening.